Welcome to my YouTube channel. In my earlier video, we solved some of the implicit differentiation, which were including algebra. Also, one of the examples involving trigonometry. This time around, it's implicit. We have the exponential, we have natural log. So I'm going to be solving this function using implicit. As you can see, the reason why it's implicit, it's because y is not isolated. It's not alone, it's not a subject of formula. For example, we know that always whenever differentiating, we know that a function x, y has to be isolated. But as you can see that we're differentiating this function with respect to what? With respect to x. But if you look at these functions, y is not isolated. Y is not a subject formula. That is the reason why we use implicit. So we are going to start with the first one. So I'm going to start with this, which is we have natural log x plus y. It's x, y equals to x plus y. So I'm going to be differentiating with respect to x, this function. So how do you differentiate ln of x, y? So you see that the argument is a product of x, y. So you know, to differentiate natural log, for example, if you have natural log x, dy dx of this, to differentiate this, dy dx of this is equal to, you differentiate inside, dy dx of x is 1. Then divide what is inside, it is x. So whenever you are differentiating natural log, you differentiate inside, which is the argument, then you maintain what is down here. Then what is inside, it will become a denominator. So this is what I'm going to do. I'm going to differentiate this one, what is inside, then as a denominator, it's going to be xy. So to differentiate this is a product rule. I'm going to use product rule. It's a function of, it's a product of two functions. You have x and y. So I'm going to differentiate. You know that to differentiate product rule, for example, you have y. If I've been given y is equal to, this is a product rule, dy dx of product rule. The formula is, you know that y prime v plus c v prime y. You get that? So one function differentiated, the other one maintained. The one which was maintained differentiated. The one which was differentiated maintained. So this is what I'm going to do. I'm going to differentiate x. Y is going to maintain. Y is going to, I'm going to differentiate. Differentiate x is 1. Y is going to maintain. So I'm going to say y plus, I'm going to maintain x. Y is going to be differentiated. Since I'm differentiating y with respect to x, it's going to be dy dx. Now, right hand side, dy dx of x is 1. Dy dx of y, it is dy dx. Now, I'm looking for dy dx. So all these expressions which has got dy dx, I'm going to isolate them. Here, this one will be here dy dx. Then this one will cross the cosine to become minus dy dx equals 1, it's here. Then this one, 1 times y, it's y. It will cross the cosine to become minus y. I'm going to factorize dy dx. Since dy dx is common, it also found here, it also found here. So I'm going to be say this one will be dy dx. If you factorize dy dx, you're going to remain with x here. You're going to remain with x here. Then here you're going to remain with what? 1. Then you have 1 minus y. Okay? So now, so this function continue, then it will come here. Since you have isolated y, here you are going to divide both sides by You divide both sides by x minus 1. Divide both sides by x minus 1. So it will come in. Then this, they will cancel. I'm going to remain with it. Dy dx equals. Then they're going to have 1 minus 1 over x minus 1. This is the dy dx over this function. So let's look at the other one. Number 2. So dy dx of the first function, natural log, we are done. It's this one. Let's look at now exponential. So we are going to number 2. I'm going to say, okay, I'm going to copy the question the way it is, then equals x, y. So you know, to differentiate an exponential function. Let's say, for example, you have y is equal to 2x. dy dx of this is you maintain this one, the whole function the way it is, then multiply with the dy dx of the power. So I'm going to multiply with the dy dx of the power. What is the dy dx of the power? It is 2. Okay, so what I'm doing is maintain the function, then differentiate, then multiply with the dy dx of the power. So this is what I'm going to be doing. To differentiate this, I'm going to maintain x plus y. Now, multiplying by dy dx of this function, the power. What is the dy dx of the power? To differentiate the power, you know that dy dx of x is 1. Dy dx of y, it is dy dx. Multiply. I'm going to use product rule again here. I'm going to use product rule. So it will be, to differentiate this one using product rule, it is 1, this one maintain, plus x maintain, differentiate y. I'm going to say dy dx. Dy dx. So now, what you're going to do is to distribute, multiply what is inside the bracket, multiply x, y power x plus 1 inside the bracket. So it will be this time 1, this exponential multiplied by this, it will give you x plus y, and this one times this one, it will give you plus, you have x plus y to be dy dx. Here you have 1 times 1, it will give you y. Then you have x dy dx. So I'll continue here. Since I'm looking for those expressions which has got dy dx, I'm going to isolate. I'm looking for dy dx. So I'm going to start writing by this. To write this one, it will be x plus y dy dx. Now, what you're going to do now, you're going to, this will cross the cosine. When it crosses the cosine, it will be minus. It will come on the left hand side to be x dy dx equals. Then here, remember that we have remained with what? But this one also, since it doesn't have dy dx, it will cross the cosine. It's going to give you minus x plus y. So now, what you are going to do now is to make dy dx the subject to the formula. You're going to say dy dx equals, if you factorize, sorry, I'm going to factorize. So if you factorize, I'm going to have ex plus y. I'm factorizing dy dx. They are going to have minus, here I'm going to have x equals to equals to y minus ex plus y. Then we are looking for dy dx. We divide both sides by ex plus y. You are looking for e minus, you are going to divide both sides. Then also here you are going to say ex plus y minus x. This will cancel. You are going to have dy dx, final answer, equals to y minus ex plus y over ex plus y minus x. So this is the dy dx of my area function. Thank you very much.